crystalline solids based on ionic metallic network and molecular solids. Ionic solids where the bonding is coulombic or electrostatic, that is ionic bonding. These physical states are hard. Electrical property is insulator, that is it cannot conduct electricity, conducting molten stenol. Melting point is very high, for example sodium chloride, magnesium oxide, zinc sulfide, calcium chloride, etc. So here are the few examples for the ionic solids. So sodium chloride, then magnesium oxide, zinc sulfide, and thus calcium chloride. So metallic solids are having the metallic bonding. Its physical state is hard. Electrical property, it can conduct electricity, as you all know. Melting point is very high. For example, copper, etc. Molecular solids. Bonding. Here the van der Waals forces of attractions has been found. There are a few examples of van der Waals forces. That is the London force, dispersion force, which have been shown by argon, iodine, carbon tetrachloride, carbon dioxide, etc. Dipole-dipole interactions where ACLs or SO2 such polar molecules will have dipole-dipole interactions. Hydrogen bonds where water molecule can exist in a solidified form, which is commonly known as the ice, through the hydrogen bonding. As you all know, whenever the molecules is spherically symmetrical, then there will not be any dipole moment, dipole. In a particular instantaneously, some uneven distributions of electrons can be take place, which has been shown in the diagram, next diagram. For this instantaneous uneven distribution of electron, it can create a instantaneous dipole in the, which is the second one, due to the instantaneous dipole of the early first one. So this is called dipole London dispersion London force or the dispersion force. Some polar molecules can be existed, which have been denoted by plus and minus, which is del plus, del minus, and then non-polar molecules can be induced to a dipole, which is called dipole-induced dipole. Similarly, here it is the oxygen one, which is a non-polar right now. In presence of an water molecule near about it will generate a dipole, which is called the dipole-induced dipole. Here it is a dipole molecule, it is a non-polar, so induce a pole in here, that's why it is called induced dipole. Here it is the dipole-dipole interaction, for example ACl, SO2, etc. For hydrogen bonding, as we all know, that rise is because of the hydrogen bonding. In the three-dimensional arrangements, it is look like this. Some other examples of the molecular solids are as follows: carbon dioxide, iodine, sulphur, rhombic sulphur, etc. Network solid bonding. Network solids is always found through due to the due to the network bonding, and which has been commonly observed in the graphite, where the three layers. Here I am showing the three layers of graphite, which have been here is dotted lines. That means they are the network bonded. Similarly for diamond, similarly for quartz, similarly for aluminum nitride. These are all our example of network solids where some networks bonded will be existed. Its physical state is very hard. Electrical property, it's an insulator, and its melting point is very high. So let's done a quick summary out. So metallic solids are having metallic bonding. Ionic solids are having ionic bonding. Network or covalent bonding will have covalent or network bonding. Basically, you just remember the network bonding only, since covalent bonding can lead to a puzzles when we discuss about the molecular solids. So molecular solids are having the London force, dipole-dipole interactions, and hydrogen bonds only. And all the compound except silica carbide, carbon, diamond graphite, and aluminum nitride, rest commonly are molecular solids. So here are some differences which have already been discussed. So let's find out some index equations. So here it is equations where you have to find out whether the molecules is whether the compound is in the ionic, covalent, or molecular solid. First, find out the potassium sulfate. Since potassium is a group 1 element, so that means it should be an ionic. So hence it should be ionic solid. Tin, undoubtedly it's a metal, and that's why it should be a metallic solid. Benzene. Benzene is not a part of the network, so it must be a molecular solid. So if it is urea, urea 2 is a molecular solid due to presence of hydrogen bonding. Similarly, ammonia 2, water molecule 2, molecular solids. Zinc sulfide. Zinc sulfide is an example of ionic compound, and thus it should be an ionic solid. Graphite. Graphite is an allotrope of carbon, and hence it should be a covalent solid. Covalent solids or network solids. Rubidium, it's a metal, and hence it should be metallic solid. Argon. Argon is a noble gas, and all the noble gases are molecular solids. Silicon carbide. Silicon carbide is undoubtedly network solid. So here is the questions. In a given compound A, which is a very hard, according to the questions, it's a very hard electrical insulator. Well, both in solid state as well as in molten state, and melts at extremely high temperature. So from the three clue, that is the hard electrical insulator both in solid and molten, and melts at extremely high temperature, we just find out that it must be a metallic solid. Since it's a hard, so it should be either ionic, metallic, or network. So molecular solids is left out. So if it is on the next clue, electrical insulator, solid as well as molten, that means ionic solid is left out. So only left out is metallic and network. And then the next clue is, here it is also, it's an insulator. So often the option available is the metallic. So hence answer should be the metallic solid. Same question says that the ionic solids conduct electricity in molten state but not in solid state. Explain. Ionic solids means the ions. So constituent particles are ions only, and such solids are formed by the three-dimensional arrangement of cation and ions found by the strong Coulombic forces of attraction. So these solids are hard, and brittle in nature. They have a high melting and a boiling point, and since the ions are not free to move about, they are electrical insulator in the solid state. If ions can be moved or electrons can be moved, that means they would be conduct electricity. But in the present case, neither the electrons of the cation or anion can be moved. That's why it must be an electrical insulator. But when it comes to the molten state or when we dissolve it in water, the ions get free to conduct the electricity. So answer should be written on the last two lines. Similarly, same pattern of questions. What type of solids are the electrical conductor, malleable or retired? How do malleable and ionic differences, metallic and ionic substances differ in the way conducting electricity? So questions answer will be on the table. So here is the first two column lies the answer. So no need to write the rest too. Already the table has been already discussed. So similar questions has been asked in the both CBSE as well as Assam Higher Secondary Education Council exam. So where they have been asked a few questions like that. Write a feature. So it will distinguish a metallic solid from an ionic solid. So same questions. What kind of attractive forces, Solomon force, and etc. have to be written. So like that. So how do the metallic and ionic solid differ conducting electricity? Ionic solids cannot conduct, whereas metallic solids can conduct electricity. Solid is a very hard electrical insulator in solid as well as in molten state. So what it would be? So network solids. Ionic solids conduct electricity in molten state but not in solid state. Ionic solids have a fixed arrangement of constituent ion, and thus it can carry current in the molten state, and the ions becomes free to move, and does it conduct electricity. What types of solids are electrical conductor? Malleable or retired? So metallic solids are the answer.